Okay, now we're getting to factoring our dots and sots when we only have two terms instead of three terms. But before we get there, I want to talk about what does this look like. Notice that we have x plus 3 and multiplied by x minus 3. Remember, these are called conjugates because everything's the same except that one's positive and one's negative. So let's FOIL this real quick and see what happens. So if we FOIL this, we get x squared minus 3x plus 3x, and then we get minus 9. Well, remember, the cool thing about conjugates is it gets rid of those middle terms because if you add them together, they just give you a 0. So we get x squared minus 9. It's called difference of two squares because the x squared is a perfect square. Because if you take the square root of x squared, it just gives us x. And if you take the square root of 9, it just gives us 3. I'm sorry, I have a crying baby. So that's what difference of two squares gives us. So let's talk about if it was sots. So notice it is the exact same thing over here, x plus 3, but it's got an I in there. It's got an imaginary number, times x minus 3i. So let's see what happens when we FOIL these together. So x times x, you get x squared. X times a negative 3i gives us a negative 3ix. And then if we multiply 3i times x, we get a plus 3ix. And then we multiply our last ones. 3i times negative 3i gives us a negative 9i squared. So what happens to our middle terms? They just cancel, just like a normal conjugate would give us. So we get x squared minus 9i squared. Well, what do we know about this I squared? Well, hopefully you guys can tell me very quickly that x squared, that what that I does is it's a negative 1. So a negative 9 times a negative 1 just changes the sign of the 9. So notice here we have x squared plus 9, and over here we got x squared minus 9. So let's look at these. So it's the same, it's just one's a positive and one's a negative. And that's the reason back in Algebra 1, if you tried to factor this, they would tell you, no, you can't. It's not a difference. It's not factorable. It would be prime. But now that we know imaginary numbers, we know that we could take that an I squared is going to change our numbers sign, so our real number sign. So now we've got to ask ourselves, the hard thing here is we've got to figure out if this is a dots or sots. But remember, before we do anything, we always have to try to see if we can take out a GCF. I do not see a GCF to take out. So now we've got to figure out, okay, dots or sots? Well, because it's a negative, it's a difference, it's going to be dots. So we're not going to have imaginary numbers in this one. So to get that, where it gets out that middle term, so there's not three terms, we know that it's going to have to be a conjugate. It has to be. So we are going to have an x and an x, and one's going to be positive, one's going to be negative. And how can I just go ahead and say that that's an x and x? Well, because if you take the square root of x squared, it's going to give you x. So that's where you get that x and that x. Now, take the square root of 36. Well, what do you get? You get 6. Okay, so I'm going to go off on a tangent real quick. So I do not want you to have to make a factor trees on these perfect squares. You should not have to go 6 and 6, 3 and 2, 3 and 2. Oh, there's a pair of 3s. So I'm going to take that out. Well, one of these should be a 2. And then I have a pair of 2s, so I'm going to take those out. And 2 times 3 gives me 6. You should be able to know your perfect squares like that. You shouldn't have to go and make a factor tree for these. So you should know that the square root of 25 is 5. You should not have to make a factor tree for that. So I'm kind of going off on a tangent. If you don't know your perfect squares, you guys need to go ahead and start memorizing them and rethinking through your perfect squares. What's a perfect square? Well, it's a number times itself. So 1 times 1 gives you 1. 2 times 2 gives you 4. So 4 is a perfect square. 3 times 3 is 9. So 9 is a perfect square, and so on. So back to our problem, we get this is 6 and 6. So now we set it equal to 0. And we solve. So we get x is equal to negative 6 and x is equal to a positive 6. So we can write this one of two ways. You can write this in your brackets and get negative 6 and 6, or you can write this as plus or minus 6. It tells me the exact same thing. So either way, it doesn't matter. Okay, next. Go to number 9. Is there a GCF? Nope. Is this dots or sots? Well, hopefully you can see that this is a positive. So, hey, Kennedy, come here and I'll help you. What's wrong? Sorry, guys. All right, so I have a positive right here. So that means it's going to be a sots, sum. And that's the only way that it can be a positive is if I have imaginary numbers in there. You want to come sit with me? Hold on, baby. Okay, so here we go. Square root of x squared would give us x and x. Okay, so what's the square root of 64? Hopefully you would say 8. So we would have 8 and 8. And again, this has to be a conjugate to get rid of those middle terms. So you have an x plus 8 and x minus 8. But the thing is that's not going to give me, if I foiled this out, it would give me x squared minus 64. And that's not what I need. I need a plus 64. So that's where I have to add in my i's. When in doubt, FOIL it out to make sure that you're getting that you know when to put i's and when not to put i's. So then I'm going to go ahead and erase this so we don't confuse ourselves. And now we're going to set each one of these equal to 0. So here, if I wanted to get x by itself, I would have to subtract over the 8i. So I get x is equal to negative 8i. And then I leave it alone. That's my answer. All I did was needed to isolate x. So now I do it on the other side. So I add 8i over to the other side, and now I get x is equal to 8i. So now you can write them as plus or minus 8i, or you could write it individually as negative 8i, comma 8i. Either way. All right, are y'all feeling okay about these thoughts? Okay, look at number 10. No GCF, it's the difference, so it has to be dots. So x squared, what's the square root of x squared? X and x. What's the square root of 121? Hopefully you quickly can tell me 11. And there got to be conjugates to get rid of that middle term. So you set them equal to 0. You get x is equal to negative 11 and x is equal to 11. So x is equal to plus or minus 11. And then we're done. Okay, let's go to 11. So this one, is there a GCF here? I don't believe so, but it looks like it's a dots. So we're going to have our binomials. Well, what's the square root of 25? 5, so you have 5 and 5. What's the square root of x squared? X and x. And what's the square root of 81? 9. So now we've got to do plus or minus for conjugates, and then we need to set them equal to 0. Okay, I'm losing, my baby is sick, so she is wanting her mommy, so I'm going to have to do this kind of quickly. So we divide by 5 to both sides, so x is equal to negative 9 fifths, and add it to the other side. x is equal to 9/5. Do you want to sit with me? X is, okay, come here. Can you say hi to everybody? Hi. Okay, so x is equal to negative 9/5, comma 9/5. All right, so yours can look prettier than mine. All right, here's a SOTS. So this time we've got to have an imaginary number to make that a positive. Square root of 9 is 3. Square root of x squared is x. Square root of 100 is 10. So we have to have 10i, positive, negative. Set it equal to 0. So 3x plus 10i equals 0. 3x minus 10i equals 0. Subtract the 10i from both sides. So you get 3x is equal to negative 10i. Now we got to divide by 3. X is equal to, okay, so with the I has to be in the numerator, or it can be written off to the side. But it cannot be written as a denominator. Remember, we are not allowed to have i's in our denominator. So you get 3x is equal to 10i, divide by 3. And we get x is equal to 10/3 I. So write them together. I'm going to write them real quick. Negative 10 or 10/3 I. Okay, I want you to try the last one on your own. So you can pause it right here and try it, or don't look up until you're done. But I'm going to work it out, but you guys can stop for a second and then work it out on your own. All right, so your answer is x is equal to plus or minus 7/2. Okay, Kennedy, can you say bye? Bye. All right, I will be there tomorrow to answer any questions. Your homework is 14 problems. They should go pretty quickly. I'll see everybody later.